To solve a specific heat problem, you'll first need to read the problem and identify your given information. The question reads, to what temperature will a 50 gram piece of glass raise if it absorbs 5,275 joules of heat and its heat capacity is 0.5 joules per gram degree Celsius? Its initial temperature is 20 degrees Celsius. So I've circled all the numbers that it gives us just to see if they're going to be important. Now, let's go ahead and look at these and identify what this information is. So, to what temperature will a 50 gram piece of glass raise? So we're looking at 50 grams. Well, grams is mass. And we may need to convert that to kilograms, but we may not. We'll look at that in a minute. If it absorbs 5,275 joules of heat, so that's my heat amount of energy absorbed, 5,275 joules, which is Q. Its heat capacity, that's also its specific heat, same thing. You'll see it worded both ways. And it's joules per grams degrees Celsius. So since my specific heat is given to me with the unit of grams, I can leave my mass in grams. I don't need to convert since they're the same. And then my initial temperature was 20 degrees Celsius. So that's everything that I'm given. I'm looking for the final temperature. So that's my unknown. So now to pick an equation, it's the only one that we're dealing with. Q equals MC delta T, or Q equals MCAT. Well, final temperature isn't in there, but it's embedded in the idea of change in temperature, which is Q equals MC, and change in temperature is going to be final temperature minus the initial temperature, and that's where we can begin. Because our final temperature is here, now we have enough to solve. We know our heat, we know our mass, we know our specific heat, and we know our initial temperature, so we can plug in our numbers and solve for our unknown. The amount of heat absorbed is 5,275 joules. The mass was 50 grams. The specific heat is 0.5. The final temperature is what we're looking for, and the initial temperature was 20. So now I can do some simplification. 5,275. I can go ahead and multiply 50 times 0.5, which gives me 25. From here, there's two different ways you could approach this problem mathematically. You could distribute the 25 inside and then proceed, or you can simply divide by 25, and that's what I'm going to do because that's less steps. And then you can take your calculator and you would do 5,275 divided by 25, which gives you 211. So you have 211 is equal to final temperature minus your initial temperature, which is 20. So since it's minus 20, we're going to add 20 to both sides. Then those cancel there. And I'm left with 231 degrees Celsius is equal to our final temperature.